Hello, I'm Ivan Lago, and this lab, number 6, treats about the Hearbleed attack, and a little bit of introduction is needed. We use the SSL, the Secure Socket Layer, which is a cryptographic protocol to secure communications over Internet. And the process is very simple. First of all, it has to be a connection, a handshake, and then verify the certificate. So the main point here is that the Hearbleed consists in to modify the request and put the size of the payload to the maximum value possible, in this case 64 kilobytes, instead of the real size of the payload. And with this, the result is the server gives you the information related with the certificate and more things that it has loaded in memory. So now we can answer a little bit these two questions that in fact are very related. The first one is what keys can be compromised, and the second one is which of the data can be of any interest from the attacker perspective. So in fact, when a certificate is created, a pair of public-private key is generated and then saved into the hard disk of the server. But the main point is that these certificates hasn't to be in the memory. Nevertheless, as we said before, since we use a program get for this lab, we realize this kind of handshake in order to force to the server to load the certificate in memory. So we could achieve both public and private key of the certificate at least, because we load this certificate in the memory of the server. But the interesting point here is that since we set the size of the payload to the maximum value, in fact you are accessing to a point of the memory set by this certificate and to the 64 kilobytes before this initial point. So in fact the attacker can take any information that is in memory. As we will see before in the Hearbleed attack, we will see information related with the owner of the certificate and a lot of more things. For example, mail, name, and other data. But basically, at some point you could get any information loaded in memory.
In this exercise, we are going to configure the Apache with SSL support on Ubuntu. First, I'm going to explain the next command. And the first parameter of this command of OpenSSL is reg, which means that by default a certificate is expected on input, but with this option a certificate request is expected instead. The next parameter indicates that this option outputs a self-signed certificate instead of a certificate request. The next option indicates that the private key generated is not encrypted. With the parameter days, we are going to specify the number of days to certify the certificate for. By default is 13 days, but 30 days. But in this case, we are going to set to 1 year. With the next command, we are specifying that we want to generate an RSA key pair of 2048 bits. And finally, with these two options, we are specifying the file where the key generated will be saved and where the certificate generated will be saved. First, we have to set up the vulnerable machine. We have to execute these two commands. The first one is to enable the SS module, which is that command, and the next one is to restart the Apache server, which is this one. Once we have restarted, we have to execute the command I have explained before, which is this command. And now we have to enter some information like the country name, the state, the locality, maybe the organization, for example UPF, my name, my email address, in order to generate the certificate. This information will be public. Then we have to set some information in this file. Then we have to configure the Apache in order to use the certificate we have just created, and to do it we have to edit this file. Here we have added our server name, which is our IP address. Then we have to check that the SSL engine is switched to on, which is set to on. And then we have to add these two lines, which is the file where the certificate and the key will be saved. And finally we have to activate the virtual host executing these two commands, and then we have to restart the Apache service. Finally, we have to restart the service, and now we are going to test if the Apache SSL configuration is working well. To do it, we have to open a browser and go to our IP address. We write it here in the search bar. And we can see that it appears a message of warning saying that the connection is not private because the operative system cannot check if the IP specified is truly the computer's IP, and that it not trust, this is what it says, untrusted, in this certificate, advising you that maybe some adversary is trying to intercept the connection. The certificate needed is not signed by a certificate authorization, so we have to add an exception and say that we understand the risk, and we add the exception and confirm. And we obtain the "it works" page. This is a risk because all the pages that depends on this certificate can sync for us using this exception, but everybody does in order to enter to the websites we want.
Hello, I'm Ivan Lago, and this lab, number 6, treats about the Hearbleed attack, and a little bit of introduction is needed. We use the SSL, the Secure Socket Layer, which is a cryptographic protocol to secure communications over internet. And the process is very simple. First of all, it has to be a connection, a handshake, and then verify the certificate. So the main point here is that the Hearbleed consists in to modify the request and put the size of the payload to the maximum value possible, in this case 64 kilobytes, instead of the real size of the payload. And with this, the result is the server gives you the information related with the certificate and more things that it has loaded in memory. So now we can answer a little bit these two questions that in fact are very related. The first one is what keys can be compromised, and the second one is what of the data can be of any interest from the attacker perspective. So in fact, when a certificate is created, a pair of public-private key is generated and then saved into the hard disk of the server. But the main point is that these certificates hasn't to be in the memory. Nevertheless, as we said before, since we use a program get for this lab, we realize this kind of handshake in order to force to the server to load the certificate in memory. So we could achieve both public and private key of the certificate, at least, because we load this certificate in the memory of the server. But the interesting point here is that since we set the size of the payload to the maximum value, in fact you are accessing to the point of the memory set by this certificate and to the 64 kilobytes before this initial point. So in fact, the attacker can take any information that is in memory. As we will see before in the Hearbleed attack, we will see information related with the owner of the certificate and a lot of more things. For example, mail, name, and other data. But basically, at some point, you could get any information loaded in memory.
Hello, my name is Daniel Pons and I'm going to perform the step number 5 of the Hearbleed Vulnerability Lab. This point is about the reverse Hearbleed and it consists in leak sensitive data from the client when it is connected to a prepared server through SSL or TLS. We're going to use Pacemaker as a server which has been developed with Python. Also, we are going to use as a client links. It's a command line browser which allows us to connect to HTTPS websites using our local OpenSSL version. Due to our OpenSSL version will be defenseless, the malicious server will be able to leak data from our client. Now let's start downloading and running the server. It is located in this Git repository, so I'm going to copy it and I'm going to execute git clone. Okay, so the server is listening on the port 4433. Now we must use an OpenSSL with the vulnerability, I mean version 101F or less. So there are a lot of repositories and sites to download an older version, and for example this. This site provides us the last version with the vulnerability, is 101F, and obviously with the warning about the security issue, which we know and accept. So I'm going to download the sources and these two patches. These two files fix some errors that the sources have. If we try to install the OpenSSL without these patches, probably the installation process will fail. So with these three files, let's try to extract, patch and install. So the method that I'm going to use is the typical way to install software from the sources in Unix systems. So using our documentation, using this site, I'm going to patch the sources from the files that we have downloaded. So patch np1 okay. Now I'm going to prepare and make the installation files using the parameters required. So I mean these parameters, these. So config with this. Okay. Now I'm going to make the installation files. I'm going to stop the video because this process takes a lot of time. Okay, so now we have made the installation file, so now we're going to install it. Okay, so now if we check our OpenSSL version, we can see that we have installed the 101F. So now we have to download the browser. So from the website, I'm going to download the last release. Is this version 288. So to install it, I'm going to follow the same steps as before. The problem is now that we are required to add SSL support to that browser. So we are going to use the option with SSL before install it. So I'm going to extract it. Okay. Okay, so configure with SSL. So now we have an error, and the problem is that this version requires an nCourse library, and to download it we can type ptget install So now with this library, let's try to configure it again. So now with no error, we execute make and finally make install to finish installation. So now if we type links version, we can see that the version is the ones that we have downloaded, and very important, this version of OpenSSL. So let's try to use links with some website. We can see that this is a command line browser. I'm going to wait, and we can move through this website, but it's not the aim of this lab. So we're going to try to connect to our fake or our malicious server, localhost 4433. So here we can see 65,000 bytes of our memory data, and it's important take into account that this information is leaked before the handshake. We can make another petition, and we got some information more. So let's try now another client, which is wget. The last version with the vulnerability is the 1.15. So let's download it from this website. I'm going to follow the same steps. So I'm going to stop the video now until I got it installed. So now I have finished the installation of this version of wget. So if we type wget version, we can take note that we got the version 1.15. So the wget allow us to download information from one server, forward it to another, and download the content. So if we type something like wget output to def null, because we don't need the information from https google.com to https localhost 4433, here we can see we have obtained a lot of information, but this information is not from Google. It's our memory mixed with our petition to Google. Here you can see information about the certificate, some mixed information from our memory. And finally, we are required to test our clients since the site to reverse Hearbleed do not work. I'm going to test our Kali Firefox, typing and if we check our server, got some troubles here. So this is the expected answer because there are very few browsers using OpenSSL nowadays. So our client is not vulnerable. So that's all. Thanks for your attention.